this, right? Testing. Testing, testing. You guys hear me? Perfect. Okay. Sorry about the delay in starting. It's always a bit crazy to be back. So we're back in person, as you can see, and as those online can also see. Everyone see the screen okay, hopefully. Hopefully all is good. Let's start in on some, administrative stuff, I guess. Looking at the state of the course as always, and then we'll go for the second extended Q&A of what's it called, of baby jail. Everyone's been having a good time in baby jail? Awesome. Okay. All right. So we are in week 5 now, solidly in week 5. I think, at least that's what it says on my slide. So that's what I'm going to go with. First, scoreboard update. So this sort of monumental shift happened in the scoreboard. We saw right when the baby jail calendars were released. HK Ray shoot up past the previous leaders. HK Ray was in 15th, shot all the way up to 1st. And by now, the top 20 and more have all solved all available challenges on the dojo right now. So good job, and keep pushing forward. It's awesome to see people working hard. So once again, this week, ASU's managed to hold the top spot, and followed by a worldwide student Bubi, and then Pi 62, renamed Owl A, Trees, and onwards. So great job. Let's keep pushing through the hacks. Why is my video like up there, not down here? I have no idea. All right, CTF stuff. Last week, 14 students played on 4 different teams, including Shellfish, and got 12 flags, not including the flag Shellfish got, because Shellfish got 8th place, which presumably included either a ton of flags or a big bribe to the Seesaw organizers. Congrats for that. So the ASU or the undergrads on Shellfish, ASU and other institutions, will presumably go on to the finals. That's very, very exciting stuff. And of course, CTFs aren't over. Next weekend, there's 4 CTFs to choose from for those interested. And that includes probably the most popular of these is going to be HacktivityCon. I've never played that one, but it looks like more teams plan to play that than the others. I have played Trend Micro CTF, always good. So any of these are going to be, I'm sure, great CTFs if you're interested in playing them. So again, grab a team of at least 4 and at most 8 students, or play with the ASU hacking ASU hacking club, who plays as Shellfish, and go do good stuff. The lights don't turn off, man. Well, you can try. It's impossible. I actually filed a ticket about the lights, and they told me that they're broken. All right. Anyways, I made a meme, so I'm excited about this one. So we have the helpfulness extra credit right now. The top 3, of course, are well, we've seen the top 2 at the top of the scoreboard there for a while in terms of helpfulness. Pi 62 and Ethan G45, great job. Derek is quickly gaining. So I made this meme. Of course, we have PyPy, CC2, Ethan G45, and Derek. And then, man, you really can't see shit. Get those. We'll bring like a BB gun to shoot the lights out in the future or something. I don't know. This is not good. Or like paintball, just paint them shut. Anyways, all right. Doesn't matter. Everyone hopefully is familiar with this meme template. Who's not familiar with it? All right, good. All right, so, oh, wait, fuck, my video covered up the meme template for people online. This is a noob mistakes all over the place. There, that's my meme. So, Konak over here, sniping the helpfulness. We all know who the most helpful person is, but luckily you can't get extra credit. All right. The tentative schedule of the class. We are in the second extended Q&A for sandboxing. Of course, I did an office hours yesterday about sandboxing. Connor will do an office hours tomorrow about sandboxing. And then sandboxing will be due and over with on the 16th at 4 p.m., which will be 30 minutes before class, and then reverse engineering is going to launch during class. Cool. How are people doing so far? If you had ended the module right now, this would have been the story. It looks like people are actually, the people that did poorly in shell coding are doing a little better in jailbreaking, but the people that did quite well in shell coding aren't necessarily doing well in jailbreaking. Like I said, it's uses a slightly different set of skills. So hopefully it'll help even out the grades, et cetera, et cetera. Of course, right now, we're still early in the process. The people that tackled this the night before it's due haven't gotten to it yet. And so there's still quite a lot of, zero, people scoring a 0 for now on this module and so forth. So this is kind of meaningless right now. Most people are still clustered toward the bottom of the completion. Otherwise, looking like this, we have some section of people that have A's, some section that have B's. But once you get to kind of that, the upper, or 60% or so of the students right now have completed less than half of baby jail. Cool. Right now, if we were to end baby jail, this is what the grades would look like. So we do have now a bell curve kind of forming, except for this gigantic set of E's. But of course, as more people tackle baby jail and start getting flags, that will go away, which will be great. No curves yet. And that is the kind of state of the class. So again, baby jail is due at 4 p.m. on the 16th. Then at 5:30, we'll launch baby rev, and actually also embryo GDB to force all of you to actually use GDB for once in your lives, people. But for most of the class after next week, when you ask us what is wrong with my solution, et cetera, et cetera, et cetera, our first answer is going to be, have you looked at it in GDB and seen what is going wrong? All right, let's get to the meme review. Again, as before, we had 3 genres of memes. One genre was kind of a general home college memes. I've actually observed this first one, the effects of it. It's very interesting. I had people coming up to me at DEF CON and asking me to take a selfie with them, which is an interesting experience for who in the end, a person is just some random noob, right? I'm a noob, more noob than most other people, in fact. Anyways, but 466 is hard. And if you're not careful, you'll see people passing on the scoreboard. Don't let that discourage you. You're amazing hackers. You can take that top spot, even if you can't take that top spot, because there was another meme that I forgot to paste in here. If you have to drive home for an hour after this class, you can still get all those points and get the belt. So don't panic. All right. There was another genre of memes, which is basically baby jail, specifically getting the fake flag in baby jail. So who here has failed to escape from a jail and gotten the fake flag once or twice? Oh yeah, that's almost everybody. Even Connor's done it. Yeah. I've never done it. No, I'm just kidding. I even had it happen in office hours yesterday. So yeah, it's good stuff. Of course, baby jail level 9, you've all now seen, or at least those who have tackled level 9 have some experience with X64's little sibling, X32. Good stuff as well. And when you're doing that, be careful to remember that it's int hex 80 and not int decimal 80. That can cost you quite a lot of time. So the third genre was trepidation for the future. Those of you who are relying on the source code, and that's pretty much everyone at this stage, right? How do you tackle a new baby jail level? You take the source code, maybe diff it against the level of the previous, or the source code of the previous level to see what changed, and then think about how that difference can lead to or can imply a solution. There isn't going to be source code in future modules. I think this is the last module probably for which you'll get source code. I forget, did we decide to do source code for other? Huh? Maybe source code for heap. Yeah, exactly. Maybe source code for heap, maybe. But you're not going to see source code for a while after this. It's going to be all x86, 64. The one true architecture. All right. And that's that. Then we'll move on from here to questions, answers, and help. Any questions about baby jail? And also, of course, if you have questions on Twitch, Connor will relay them to me and we'll get them answered. Yes. That what?
Level 12.
Uh-huh.
You said you have to get data feedback, but how do you get it?
Yeah, so there's a number of ways to get that side channel feedback. Level like 9, 10, 11, and 12 are different explorations of ways to establish and communicate data across a side channel, not a direct communication channel, because you can't write, right? So one way to do it that you have full control of, no matter what seccomp, sandbox, and so forth is there, is you can choose to crash, right? You can choose to crash or not to crash. Now, how do you not crash if you're not allowed to exit? Think about it. How can you prevent your program from crashing? That's kind of the key to that one, right? If you're allowed to exit, you can, of course, exfiltrate data through the exit return code. If you're allowed to do other system calls, you can exfiltrate data in other ways. Any sort of externally measurable effect on the execution of the program that your shellcode can induce can become a side channel, as long as your other side of that side channel is able to measure it. So that's one thing. The other thing that someone very cleverly came up with is there is a way to measure how many bytes have been read from a Unix pipe. I haven't actually looked into this, but Connor, you looked into it, right? Yeah, you can actually figure out how many bytes have been read from a file descriptor. You can use that to communicate outwards. I don't personally know how to do this. You have to Google for it, but I know that it is doable. Cool. All right. Any other questions on jailing concepts, sandboxing concepts? All right. A couple of things that I wanted to run by. One thing is, why can't you chroot as a user, right? So whenever you strace or otherwise debug any of this stuff, we keep telling you, make sure to use practice mode, make sure to use root, right? And in fact, if we just grab like level 1 and walk through it, all right, so we're going to I don't have my key here, do I? I'll just use the terminal here. All right, so if we run baby jail, and of course with the clever solution of grabbing the flag, things work. We create a jail, we open the flag file, we're root, so we can do it, and we run. So of course, baby jail runs as root because it's set UID. But if we run it in strace or GDB or anything that like debugs it, this won't work. And why won't it work? It won't work because chroot will fail with an operation not permitted. Okay, so as I kept saying in office hours and so forth, hey, this happens because you don't have the permissions as a user to run chroot. Chroot requires root access. What is actually the case is that chroot requires a capability that root has and that most normal users don't have. So if you look at the man page, actually, if you look at the man page for the actual system call, we have here, only a privileged process may call chroot. But what is a privileged process under Linux? And of course, this varies in the other operating systems. Under Linux, chroot can be called with the cap sys chroot capability. So what does that mean? Well, it turns out that every process in Linux, again, every process, not every user, not every program, although that does blur a little bit, every process running in a computer has an effective user ID, has a real user ID, has an effective group ID, has a current working directory, has a set of capabilities. That set of capabilities can be retrieved using get cap and set cap. No. I just drew a blank. How do I look cap sh? So you can do cap sh, and we're kind of YOLOing things here. So there's going to be a little bit of remembering on the fly for me. Okay. Cap sh list. Oh. Cap sh dash current. Go to the man page. Maybe dash print. Cap sh dash print. Big success. Okay. So all of these capabilities that your process has get inherited typically by your children processes. And when I run as my shell cap sh, it gives me the list of capabilities that cap sh really has, the cap sh process, but these are whatever inherited capabilities that whatever capabilities cap sh inherited from my shell. So unless some other trickiness is happening, this is the set of capabilities that my shell has. I have this. Wait, why do we have capdac override, Connor? And why do I have caps to chroot as hacker? Hold on. This is what happens when we go off script. We definitely don't have cap. If we copy this. Yep, chroot fails. So I don't have so I don't have caps to chroot, but why does this say I have caps to chroot? Well, let me move this so it's less in the way. Okay. This is the capability I need to use chroot. Yeah. Let's look at bounding. Where's my, yeah, current? None. That makes more sense. This makes no sense. Unless kappa sh is set UID for some reason, but it wouldn't be. Let's run a simple shell. I have no idea why that user has all these capabilities. All right, if you look at my machine, this is what we expect to see, which is that this current process has no capabilities, right? So there's a lot of capabilities that you could have, including capsys chroot, which would allow me to execute chroot, the chroot system call, but I don't have that capabilities. But when I am root and I do the same -h print, we really shouldn't have gone off script. Current EP. And get cap is definitely on a file basis. All right, I am going to abort this demonstration. It didn't work out. That's okay. We'll dig deep down inside and figure out why this claims that that my shell has the capability to do a chroot, even though it demonstrably, when I try to do a chroot, doesn't have that capability. Right. Well, let's try chrooting. Yeah, operation not permitted. But for now, we'll accept that mystery. The interesting thing is, so I said capabilities are something that a process has, right? Not something that a file has, et cetera, et cetera. That's not actually quite true. There is metadata associated with files on Linux that allow you, in the same way as the setuid bit flag, in some sense, the setuid bit flag sets the process that a file, that a program on the file system gets launched as, right? That's exactly what it does. You can also set capabilities that a process will have using the get cap and set cap commands. So if we do set cap, and this is going to be a total YOLO. Let's see if we find a example in the man page. No, but you know what? We can, so set cap. Let's just find an example here. I'll show you. All right, so we can set so we set cap. We copied our v1 file here. This is the challenge. I can run it as root, of course, but I can't run it as the user because it won't be able to root. I can do a set cap sys chroot. I can add it as effective inherited permissible capability onto this file. Let's see if this flies. Seems to have flown. We can get cap. Okay, so now we should be able to run this even as a user. No. All right, I think this is a lesson in YOLOing demonstrations. We're gonna chalk this one up to a complete fail. All right, that's fine. The point is, capabilities is what truly guards access to certain certain actions that root can take that users can't take. Root, in some sense, is a bundle of capabilities that lesser users just don't have. One of these capabilities, it's called cap-dac override, is what allows root to read any file, for example, to ignore file permissions. Cap chown allows root to change ownership of files. Capsys ptrace allows you to ptrace other processes, and so on. It's a lot of very good stuff. Cool. I guess that was a clusterfuck. That's okay. All right. Any other questions on any question on capabilities, on jailing in general still, chroot, seccomp? Anyone on Twitch asking for anything, Connor? Awesome. It's a pretty chill day today. Hold on, let me blow my nose. Try to mute everywhere to save people. So everyone here is done with Baby Shell and not stuck at all? You're done? Wow. Cool. I'm sorry? No. Oh, hi. Oh, good job. Awesome. Awesome. All right, everyone's done with Baby Shell. No questions. Damn, then what are we gonna do here? All right, let's talk about on level 3. Let me take a look at level 3 real quick, and then maybe we'll start in on some maybe GDB concepts would be good to get up to speed. But all right, let's take a look at level 3. Level 3, did I do it all the way yesterday? Yeah. All right. So let's just take a speed run, because I did it from the perspective of 2, but I ended up with a solution that worked for 3. So what does 3 do that's new? Of course, 3 asks for shellcode, right? You can still open a file, but you can't have the word flag in it. So we can open slash. This gets opened before this first gets open, and then the jail gets created. So slash is owned, sorry. The slash that is opened is the real slash from outside of the jail. And then shellcode runs. What this does not do is chdir, which after doing the chmod, which means that there are 2 different ways to solve this. I mean, there's even more than 2, but there's 2 very easy ones. We have the typical situation where it does do the chdir. Never mind. So it properly jails. All right. Okay, I see the confusion. That's what it does that level 2 doesn't. Okay, so all we have as a lifeline to outside of the jail right now is this /, the root directory that we opened before creating the before jailing ourselves into temp jail, whatever we create, right? And then our shellcode runs. So we have, if we strace, we have, here's the jailing. Here is before the jail when we open the provided file, so slash. And that gives us file descriptor 3. And then we run our shellcode. And of course, our shellcode runs in the context of this program, where file descriptor 0 is standard in, 1 is standard out, 2 is standard error, 3 is the root directory outside of the jail. If we opened slash after this call, we would be opening what is really temp jail, blah, 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 right? But the process did it before the ch root, and so we ended up with the true root as file descriptor 3. This allows us to use openat, or the way to solve this is by using openat. It is a system call that will give us that will open a file relative to not the current working directory, although there is an option that that's how it will work, but relative to another directory that is open already as a file descriptor, right? And in this case, that will be directory 3, which will be our or that will be file descriptor 3, which is the root directory that we've opened before the jails happened. So let's see what's a.s here. All right, since my shellcode's on my other computer, we're going to just recreate this shellcode in here, like I should have done all along. It's going to be our openat shellcode. So we're going to openat, then we're going to read, and then we're going to write, and then we're going to exit. We know how to exit, right? Move RAX 60, move RDI 42, syscall. All right. Right. Also easy. What is the system call number of write? Huh? Should be 1, but we can do syscall.sh to find out. Yep, 1. We will, okay, RX1, move, okay, and then we will syscall. What do we need to do? We need to say where file descriptor we're gonna write out to file descriptor 1. We'll say from where we'll read shellcode, or we'll read the flag onto our stack, and then we're going to have to say how much, and this is whatever the read syscall will return, however many bytes the read syscall will read. Okay, so then here's read. So openat will, actually, I'm going to stop writing this backwards and write the openat. All right. How does openat work? Openat works like open, but with a file descriptor. Here it is. It takes the file descriptor, the file name, the flags to open with. Of course, flag 0 is open read only. And then it will take the mode if you're creating the file. So nice and simple. RDI is 3. That's our file descriptor representing the slash outside of the jail. RSI is going to be our path to our flag. We'll use rip relative addressing here. And here, instead of slash flag, we're going to put flag. Why is that? Why not slash flag? We're already in the root directory, so we don't have to do slash flag. But there's actually one more problem. If we do slash flag, it won't work. We'll resolve relative to the actual, to our process's root. Open at, in some sense, will ignore that first file descriptor, the file descriptor that happens to be pointing to the root outside of the jail. If a file name starts with slash, it'll just ignore that, and it'll look up starting from the ch root, the root of the current process, which is inside our jail. So we just do flag. All right, just a couple of things missing. Move our DX, how much we want to read. No, sorry, where we want to read to. And then we move our 10, how much we want to read. Right, is our 10 correct? Our 10 is correct. Awesome, okay. And then we move RAX. What's the syscall number for open at? 257. All right, and then we just need to, wait, sorry, what am I doing? No one stopped me. I mixed up read and open at. This is for read. This is what happens when you know, like after being sick, you go, you know, back to school or whatever, and you're just like kind of still a bit of a shock to your system. It's much easier to just kind of get up and go to the desk and start teaching. All right, the path. What is open at have other than the path is the flags. That's all we need here. You don't need any R10 or anything. Move RDX 0. This will do open at of this relative to this file descriptor of this file name in this mode. That 0 is read only. Here we prepare the read syscall. So RSI was where we want to read it to. Our DI, the first argument, the file descriptor we want to read it from, which is whatever open app will return. It's always going to be 4 in this case, just the next file descriptor, but let's just get that return value. RAX will be 4. And then RDX will be how much? We'll read 100 bytes. And then RAX will be the read system call number, which is 0. And we do a syscall. Okay. We're going to compile this. Or assemble it rather. And we're going to extract it. Is it the other way around? I always forget. No, it's not. This can't be it. No. This is why I always have a script that does this. Dash dash dump section. Okay, that was a bit of a terminal mess up. Okay, and now we can try our solution. And it works. So again, we pass in slash to baby jail level 3 to get a foothold outside of the jail. The moment we have a foothold outside of a jail, typically that jail is now broken. It's too easy, at least in Linux, to start crawling around resources relative to other resources. In this case, we had a resource outside of the jail, which was a file directory that we had opened, and we were able to use that to escape the chroot, right? Functionally escape the chroot. And in fact, kind of similar analogous situations to this are used to escape much more modern file directory encapsulation techniques. You can probably escape, could you escape a mount namespace in the same way, Connor? What do you think? Mount namespace, if you had a file descriptor from before. Yeah, you probably could. Yeah. So it's actually a future direction of this module that we're looking at is kind of the modern sandboxing, like chroot alternatives, mount namespacing and so forth, used by Docker, but probably also escapable in very similar ways. Cool. All right. So that's a much better write-up of walkthrough of number 3 than I did yesterday, because yesterday's number 3 was kind of combined with number 2. All right. Other questions? I can talk about level 8. Let me show you. All right. So here we are in level 8. Let's see what we're up against. All right. Level 8 allows us to do an open at, a read, a write, and a send file. And it does a proper chroot jail. So it does a chroot and a chdir. Oh, that's right, level 8. Yeah. Okay, so what's the difference between level 8 and level 3? Or at least our solution to level 3. Yeah. So I could pass in, except for my clean exit, I could pass in the same shellcode from my that I passed into level 3 into level 8. All right, what's missing? There's one thing that my shellcode used in level 3 that's missing from this level. So let's look at my shellcode in level 2. And actually, because I'm jumping back and forth between levels, let me real quick. Let me create a new key and put it so I can SSH in instead of using, oops, profile, nope, settings, SSH key, place it with this one. Awesome, okay. Okay, so here's level 8. Let's launch level 3 and just redo that solution in strace, so we see exactly what it does. All right. Here is my solution, right? Simple open at, read, write, exit. I'm going to remove this exit because level 8 doesn't allow us to exit. But, of course, that's not just comment it all out. That's not really important. Oh, man. All right, so boom, now it doesn't have the exit, so it'll just sec fault eventually, no problem. And we run baby shell level 3, we get our kind of foothold out of the jail, and we boom, right? So let's strace that, see what happened. Of course, we need to do this as root. All right, sudo strace. Here's our shellcode running. Open at 3 flag. What is 3? 3 is slash opened before the jail, before we were put in the jail. Then we read, then we write. Or instead of read and write, we can use the send file syscall that does both of them at the same time in some sense. But whatever, this is more straightforward. So open, read, write, open at, read, write, and the open at did file descriptor 3. Now I'm gonna cleanly log out. Okay, and then let's launch level 8 and see what's preventing us. Level 8 is a properly formed TechComp sandbox. All we can do is open at, read, write, send file, right? So we are stuck with kind of the same shellcode, but there's one critical difference. If we strace this, first it's not gonna ignore this slash, it doesn't open anything. And of course, when we did this open at 3, it said bad file descriptor. What's the file descriptor it's referring to? It's referring to file descriptor 3. Why is file descriptor 3 bad? Because there is no open file outside of the sandbox that it gifts us, right? So this challenge creates a jail and doesn't give us anything outside of this jail. So what's missing to be able to use the exact same solution on level 8? The ability to open a file outside of the sandbox, right? Think back to Embryo.io, right? Embryo.io taught you how to solve this. This is a combination of level 3 and concepts that you've seen in Embryo.io. Awesome, because in the end, your process is the parent of this process. Your process controls much of this process's context that it's running at. And that allows you to solve this. Cool. I think with the discussion of this makes, I think we've now touched on every single challenge in, we touched on 14, we touched on the side channel ones, touched on 7 yesterday, 8 today, or yeah, this is 8. Yeah, so everyone should have full solves this module. All right, more questions? Yes. How Nano Sleep works. All right, so first I'm going to show you how to use Nano Sleep. Nano Sleep, that's like level 11, yeah. All right, so of course, level 9, 10, 11, 12, they're these side channel levels. They're really like your jail is such that you cannot directly communicate. So let's look at level 11. All you get is read and nano sleep. So you can communicate out to the world using at least one of these. This is, of course, a solvable level. Let's start with looking at nano sleep. First thing, when we're looking at nano sleep, man page. Nano sleep takes two structures, a rec structure, which is they're the same type of structure, a time spec. One of them is the requested amount that you'll sleep. The other one is when it's an out. This one is an input parameter. This one's an output parameter. If your sleep is interrupted, for example, with a signal, then this parameter will be populated by how much sleep time was remaining. The struct is pretty simple. There is a time t of how much to sleep in seconds and a long of how much to sleep in nanoseconds. And of course, you can figure out the exact sizing of this in C. So let's include time.h, and we'll just use nanosleep here. So we include time.h. Here is int main, and we're going to do struct time spec ASDF, and we'll printf size of the seconds argument, which is really all we really care about, but also here we do size of ASDF.seconds and the size of nanoseconds. Okay. Struct time spec has no, right? TV underscore sec and TV underscore nsec. Hope. Okay, here we go. Some warnings, but that's okay. All right, we run NS, and Connor, do you have a USB-C charger? Anyone have a USB-C charger I can borrow? Brilliant, thank you. Oh, it's perfect. It's a Lenovo. Thank you. I got mine, and my laptop just told me that was a bad idea. All right. Phew. So we have a struct made out of two 8-byte arguments, and by filling these out to appropriate values, let's say we wanted to sleep for 2 seconds and no nanoseconds, and calling nanosleep, passing that struct. And actually, if we look at nanosleep, it'll tell you that REM can be null. So we're just not going to worry about it. All right. We compile this, we run it, and we see that it's sleeping for 2 seconds. How can we verify that? We can verify that using the time command, or just by manually writing a utility like this. This will, the time, actually, time is both a program and a built-in. If you just do time, you're using the bash built-in. If you use user bin time. What? Interesting. Maybe the time command is something that has to be installed specially. Anyways, the time built in will tell you how long your program took. This took 2 seconds, right? Of course, we can also do this in assembly. In fact, of course, this GCC, we can disassemble the resulting nanosec file, or we can just write our own. And it's super simple. Can someone look up the syscall number of nanosleep for me? 35? Awesome. So RDI has to be a pointer to something where we'll store the data, and we can store this data here as keyword pointer. RSP, we sleep for 2 seconds and 0 milliseconds. And this should be it. Success. 2 seconds. Oh, and probably let's exit cleanly. Better. All right. So the when we do a sec fault, there's some processing that happens in the kernel, et cetera, to try to save our core dump up, or at least to look up if it should be saved. That takes some time. But here is our nice and clean 2 second sleep. So already, what are we communicating out? We're communicating this number 2. Now, of course, that number 2 could be any number. We can communicate out the number 5 just as easily, right? We didn't write it out directly, but by using it. Hey, guys in the back with the conversation, you can totally have it, but if you could have it outside, if you guys need to have it right now. Okay, awesome, thank you. All right, so you can just as easily communicate the number 5, right? Now, it is just a parameter here in your code. Of course, if you have to communicate very large numbers, let's say, what is lowercase p hex 70, right? That's going to take us a while. It's 112 seconds that we're going to be sitting here for, right? If you're communicating, let's say 1 letter of the flag at a time, you're communicating like that, that's going to take you a while. So what if you use this, right? Because you can sleep for 0 seconds and 1,000 milliseconds. I don't know if this actually makes enough sense to measure, but nope, too little. 10,000. Wait. Yeah. Too little. 100,000. Okay, nanoseconds should be 6, right? What's going on here? Okay. I'm just a little discombobulated, but you can see that we can actually measure down to the microsecond granularity, right? microsecond, the millisecond. Okay, yeah. And here we can sleep at granularities that we can definitely leak out or correlate accurately from the outside. So if you wanted to send out that letter P, then here is almost all of it, maybe not very reliably leaked. But if you had another order of magnitude, we have to be careful here. If we do it like this, and here we have leaked very reliably 1, 1, 2, just in the timing. Cool. All right. Other questions? Remember, your side channel doesn't have to communicate the entire flag all at once, right? The flag doesn't change between executions. And this goes for all of the challenges in pwn.college. If you run the challenge, you can get any information about the flag and you can vary that information, get that first byte, then the second byte, then the third, you're home free. You can do it one byte at a time. All right. That brings us to the end of class, unless anyone has more questions. If you do develop more questions, because I know that some people haven't started yet. If you do develop more questions between today and tomorrow, Connor will have his office hours tomorrow. Then we'll go on from there. And on Thursday, the reverse engineering module launches, and we'll send out the tonight. We'll put up the videos for that. Awesome. All right. Good luck. Ciao.